Hi, my name is Cosimo Pecchioli and I'm with Alfa Laval Data Centers Cooling Solutions. And today we talk about distribution of the fluid inside a heat exchanger and through the plates. When we talk about efficiency of a heat exchanger, and even distribution of the fluid is probably one of the key aspects, along with the design, of course, of the plates themselves. So what exactly is the challenge? Well, first of all, if you imagine, then this is the inlet, let's say the cold inlet, which normally is the more challenging because it comes from the cooling tower, so you might have debris, you can have fouling issues, so the cold inlet normally is the most challenging one. And that's the reason why we suggest to always put it at the bottom of the heat exchanger and not at the top, so you can take advantage of the positive pressure coming from the pump. So you imagine that this is the inlet. The first challenge that you have is to have an even distribution throughout the plate pack, which means that you might remember that we have high theta and low theta plates, that they have different pressure drops. So you want to stack your plates in a way that do not have an uneven distribution throughout the plate pack, meaning if you put the higher pressure drop plates in front of the plate pack, of course you facilitate an uneven distribution because you will have a higher flow in front of your plate pack and you will have a challenge in reaching the end of the plate pack. While if you put the higher pressure drop plates in front of the plate pack and then the lower pressure drop plates at the bottom of the plate pack, you minimize this effect. So you have this cold flow going up, and you want to design your plate pack in a way that you cover the whole length of the plate pack. And considering then in large heat exchangers you have up to 800 plates, you can see how this plate pack can be very wide and the distribution needs to be taken in account. Now, how maximize this efficiency? Well, this is a plate, of course, so these are all the plates that you have here, and this is the channel, of course. In this case, this would be this channel, of course. So I don't know if you know this, but this part is not actually round, it's oblong. And this is a new design that Alfa Laval introduced in 2018, and this is to facilitate an even distribution through the plate pack. Of course, the ports at the frame, they're round, so they can connect with the piping. But inside of the heat exchanger, the distribution is facilitated by the shape of this port. And then you want to maximize the distribution of the fluid through the plate. And this is challenging because, of course, as you can see, the inlet port in this case, which is opened by the gasket, the inlet port is offset in respect of the rest of the plate. So this area, which is called the distribution area, of course, of the plate, plays a key role in making sure that you cover as much as possible this plate with an even flow of your fluid. And a key aspect, of course, is you want to have a pressure drop of this path, which is as equal as possible to the pressure drop of this path, so you don't have a path of less resistance and cold spots or hot spots that increase the chances of fouling. And this is exactly what this design does, and has been proved that the increase in efficiency is actually significant, up to 25–30%, which is amazing if you think about that. And that is another reason why we say that the heat transfer area, so the amounts of plates that you have in a heat exchanger, is not necessarily a good indicator anymore of comparing apple to apple, because if you have a higher efficiency plate, you need less plates, and so you can achieve the same duty with less heat transfer area. We talk about a lot of concepts in this video, high theta and low theta plates, and the distribution area, main heat transfer area. You find all these concepts in previous videos of this series if you want to, let's say, have a look at them. And thank you for watching this video and have a great day.